So our last example is not a polynomial. We have f of x is 2 over x minus 1 on the interval from 0 to 4. And I actually think this is a little bit nicer because we're not going to have to factor, which is always great. So we're going to start by taking the derivative, but it looks like a quotient rule. I do not have to use the quotient rule though because I don't have x's in the top and the bottom. So the first thing I would do is just rewrite the original function. 2 times x minus 1 to the negative 1. Now I'm ready to take the derivative using the chain rule. So I'm going to keep the constant 2. Bring down the power of negative 1 though. So 2 times negative 1 is going to be a negative 2. So I brought down the power of negative 1. I keep the original on the inside. Subtract 1 for the new power. And then the last part of the chain rule is multiplying by the derivative of the inside, which is just 1. So I bring down the negative 1, raise the whole thing to a negative 2, multiply by the derivative of the inside. And I'm going to set this equal to 0. So our methods to solving is that we have to factor, which we don't because we don't have an x word and an x in this one. Or we have a linear function, which we don't because we don't just have an mx plus b. Or we just have to rewrite negative exponents back in the denominator. So that's going to be the method we use for this one. We're going to put this negative exponent piece into the denominator. So putting our constants together, we have negative 2 times 1. Well, that's just going to be negative 2. And then we're going to do x minus 1 to the positive squared in the denominator. And we're going to set that equal to 0. So a critical number can make the top 0, but negative 2 is always negative 2. Nothing can make that 0, or it can make the bottom 0. We can make x minus 1 0, which actually works if x is positive 1. So we have one critical number. We're going to look on our interval. And remember, this might not be a critical number. If we can't plug it in, we wouldn't technically call it a critical number. But for this one, we're not determining do we have critical numbers or not. We're just comparing this number to our endpoints, as long as it's in between. So we have f of 0 and f of 4, and that may not technically be a critical number just because it made the derivative undefined. But is it between 0 and 4? Yes. So we'll test it. We'll see, is it really a critical number? Does it go into the original or not? And then we'll also see, is it an absolute max or an absolute min by plugging it in. So if we look at the original function, we're going to do 2 over 0 minus 1. So 2 divided by negative 1 is going to be negative 2. For the next one, we have 2 over 1 minus 1. We would get 2 over 0, which is undefined. That's a vertical asymptote. It is not going to give us an absolute max or absolute min. It's actually technically not even a critical number because it can't go into the original. So this is definitely not going to give us an absolute max or an absolute min. We have a number divided by 0. It's a vertical asymptote. It's going way too crazy to say here's the absolute max where it stops or the absolute min where it stops. This is not a point on the graph. And then if we look at f of 4, we would plug in, we have 2 over 4 minus 1, and we get 2/3. So, looking at the only two y values we have, we want to figure out which one's the highest and which one's the lowest. So we'd say the lowest is negative 2. It's our absolute min. And our highest is 2/3. Our absolute max.